Hey, what's going on YouTube subscribers, new listeners? You're watching KBTV, where knowledge is born, and I'm King David. Salutations and greetings. How y'all doing today? Today's segment is space water. Okay, so that's the lesson for today. Um, you know me, I like to jump right on in. I don't like to waste too much time. All right, so let's go ahead and born knowledge, because we all here to learn. All right. Um, First, let me start off by reading this article. Um, the exosphere, which is the outside eternal body of the planet, okay, is a thin atmosphere like volume surrounding a planet or natural satellite. Natural satellite can be the moon. That's Earth's natural satellite, by the way, where molecules are gravitationally bound to the body, but where the density is too low for them to behave as a gas by colliding with each other. Because remember, we got gas, liquid, solid. In the case of bodies with substantial atmospheres, such as Earth's atmosphere, the exosphere is the uppermost layer where the atmosphere thins out and merges with interplanetary space. It is located directly above the thermosphere. Very little is known about it due to lack of research. Okay, so let me stop there. And this is the exosphere. Okay, it's 400 kilometers, which is 258 miles from the Earth's surface, from where we're at. Okay. Um, they know much about the exosphere. Okay, this is the highest of our atmosphere right here. They know little about it due to lack of research. I want you guys to remember this. Okay. Mercury and several large moons, such as the moon and the Galilean satellites of Jupiter, have have exospheres without a denser atmosphere underneath, referred to as a surface boundary exosphere. Here, molecules are rejected on elliptic uh, trajectories until they collide with the surface. Smaller bodies, such as asteroids, in which the molecules emitted from the surface escape to space and are not considered to have exospheres. Bear with me, y'all. The most common molecules within Earth's exosphere are those of the lightest atmospheric gases. Okay, hold on, let me read that again. The most common molecules within the Earth's exosphere are those of the lightest atmospheric gases. Hydrogen is present throughout the exosphere, with some helium, carbon dioxide, and atomic oxygen near its base. Because it can be hard to define the boundary between the exosphere and outer space, the exosphere may be considered a part of interplanetary or outer space. All right. I'm just gonna stop right there and come back a little bit later, but I'm gonna write down right next to the exosphere, which will be, I'm gonna write down high hydrogen, which we all know hydrogen equals water. Okay. Now bear with me, y'all. I know y'all thinking, what? Space is water. I know. But you gotta understand how we've been conditioned and lied to and over again. Just picture everything that you've been taught, flip it upside down. Because that's what they did. All right? But bear with me. So let's go back just a little tiny bit. The top of this is 258 miles above the surface. They know little about the exosphere due to lack of research. But what they do know is made of some other particles, but mainly hydrogen, which we know what hydrogen is water. Okay. And just for pointers, thermosphere, the word thermos in Greek means heat. All right. So when you're going in and out of our atmosphere, things have to heat up. Okay. Now, I'm going to read something else to you guys. Bear with me, y'all. Bear with me. Okay. A potentially dead spacesuit water leak that nearly drowned an Italian astronaut during a spacewalk last July was one of the scariest close calls in NASA spacewalk history. In fact, the spacesuit also leaked during an earlier spacewalk, but went undetected at the time, according to a NASA report released today, February 26th. They're talking about back in July 16th of 2013. So this is 9 years ago. Okay, the announcement came as NASA released the results of an investigation into the Horring spacewalk on July 16, 2013, in which water flooded the spacesuit helmet of Italian astronaut Luca Parmitano, forcing NASA to abort the spacewalk to get him to safety. In the end, the malfunction was completely unexpected and unlike anything space agency planned for. All right. NASA officials didn't realize that the leak has also occurred at the end of a spacewalk 1 week earlier on July 9th. Parmitano and his fellow spacewalker, NASA's Chris Cassidy, thought the water in the suit after July 9th was the product of a leaky drink bag. So they had a drink bag, like how you carry your backpack and you got a drink bag in your backpack, just like when you go mountain climbing and things of that nature. That's what they had, and they thought that was the cause of the leak in his helmet. Okay. If the water buildup after the first spacewalk had been discussed in more detail, mission controls probably would have realized the issue needed to be investigated further before pressing ahead. Okay. Parmitano's cool head helped keep him safe as he made his way back to the airlock. Calm demeanor in the face of his helmet filling with water possibly saved his life. Parmitano's helmet began filling with water just after venturing outside of the space station on July 16th. Eventually, the water filled his eyes, ears, nose, and part of his mouth, making it difficult to breathe. About half an hour into the EVA spacewalk, 45 minutes maybe, Chris and I were headed on our task. So we were starting our third task and I felt some water on the back of my head. I realized that it was cold. It was not a normal feeling, so I told ground control. Okay? So, this is an astronaut, okay, that was doing a spacewalk. Now, understand, gravity stops where you begin to float at 250, right in between the exosphere and thermosphere about like right here, you'll begin to float. Okay, so because this is about 400 kilometers, and astronauts go about that high, or but a little less. They go a little bit less, probably like 300 kilometers. Okay, and uh, anything past that, it's going to be water. Okay, so during their spacewalk, he ended up getting water in his suit, as I just read. Okay, and we just pointed out at 258 miles exosphere, which due to lack of research, what they know about it is that it's made of other particles, but mainly hydrogen, water. So that's the reason why he got water in his suit. It wasn't because of a drink bag, okay? And this is something that they were not prepared for, right? But let's think about where astronauts train at, okay? Remember, they train on Earth, but where do they train at? They train in a giant Olympic-sized pool, big, lots of water. Why water? Because I mean, how many people are running to be an astronaut as their career choice? Not too many. And the ones they do, I'm sure they have to take an oath because they're going up seeing stuff that other people don't. All right, which will reveal the truth. But that's where we're getting to, the truth. So they know that space is water. That's why they train in water. Okay. Or at least now they do. Okay. Also, you know, if space is water, how are those satellites going to the outer part? How are y'all sending satellites through water? Okay. And y'all just told us, y'all just admitted that the exosphere is water, mainly water. So how y'all sending satellites all the way to so-called Pluto and other planets? And they've been probing out there for 8 years. You know, you're taking pictures of different galaxies and stuff like that. You know, without the satellite getting damaged or getting hit by any debris in the space and things of that nature. Come on, it's a little far-fetched. So we gotta start using our minds. Okay. Now, when they talking about outer space, they're talking about the outer limits of our world, of our Earth, not the up part. Okay, the up part in space is where I just explained. Okay, it's water right there. Okay. And I got a list of things right here. I just want to go over real fast, but not too fast to where we don't understand. So let's just go back a little bit. Okay, exosphere, 400 kilometers, 258 miles, hydrogen made of water. Astronaut Luca Parminato spacewalk. Okay, got water in his suit. All right. So all that talk about they've been to the moon. How did Neil Armstrong back in when Kennedy was alive get to the moon? All right, first they already admit that they have to go through the Van Allen belts. Okay, the Van Allen belt is a radiation belt that surround our Earth. Okay. Thousands of miles up above our Earth. It's a radiation belt. Okay, they call it the Van Allen belt. They already admitted that they haven't even figured out how to go through it. Okay, let alone go through it, go to the moon, and then come back. Okay, remember I said the thermosphere. The word thermos in Greek means heat. It means heat. So when you're going up and in and out of the atmosphere, you're going to heat up. Space shuttle and all. The space shuttle, all right? on top of radiation. Once you get past this, then you got to deal with the radiation. So they already admitted that they never haven't even got to the how to figure out get past the radiation belt, which is the Van Allen belts. Okay. And then they admitted that they claim they can't make the technology that got them there the first time. Now this is back in the '60s. You mean to tell me you don't have the technology today to get back where y'all went 60 years ago? 70 years ago? Come on now. It's a little far-fetched. So, you know, that's just to add more, you know, truth to the lesson today. Okay, is that space is water. Okay, and they didn't get to the moon. You know, they still having trouble today. Okay, they're having how did if that was the case, he would have drowned getting to the moon. Okay, they're having trouble today with the spacesuits and getting water leaking in the spacesuit on the spacewalk. Okay, so that alone is just it's not accurate to what they've been trying to teach us. All right. So they know the truth. They train in big old pools. They know what's going on, right? Also, to top it off, okay, I got another article I want to read. While normal blood pressure will keep a person's blood from boiling, the saliva in the mouth could very well begin to do so. There's actual evidence for that happening from an astronaut who experienced it in 1965. Remember, this is back when they went to the moon, right? While performing tests at the Johnson Space Center, a subject was accidentally exposed to a near vacuum, less than 1 psi, when his spacesuit leaked while in a vacuum chamber. He did not pass out for about 14 seconds, but by which time unoxygenated blood had reached his brain. Technicians began to repressure the chamber within 15 seconds, and he regained consciousness at around the equivalent of 15,000 feet of altitude. He later said that his last conscious memory was of the water on his tongue, or the saliva on his tongue began to boil. So there's at least one proof or data point about what it's like to be in vacuum, okay? And we know the space is not a vacuum according to Albert Einstein's theory of space being a vacuum, okay? Because they just proved it right there. Your blood will boil from the inside, including with your saliva. Okay, and he didn't last 2 minutes. Okay. Now, going in a little deeper, y'all. I don't want to hold y'all too much, but going in a little deeper. All right, I gotta get into the Bible because it all coincides. All right. So let's start from Genesis, chapter 1. I'm going to start from verse 6, okay? And God went on to say, let an expanse come to be in between the waters, and let a dividing occur between the waters and the waters. Then God proceeded to make the expanse and to make a division between the waters that should be beneath the expanse and the waters that should be above the expanse. So as above, so below. Like I mentioned in my other videos, as below, so above. As below, as below, so above. As above, so below. So there's waters above us, okay, which we just talked about in the exosphere and beyond, okay. And then you got the waters down on the normal surface where we at. Okay, where we live at. And God went on to say, let the waters under the heavens be brought together into one place,